Hey, what's going on? I'm Jamie Blake, and in this video, I'll be talking about the concept of CV, or control voltage. So let's get into it. So before MIDI existed, we needed a way to control different parameters or modules on an analog synthesizer. The way this was done was using control voltages. Now, control voltage at its core is essentially just an electrical signal, much like an audio signal. Control voltages can be used to control, say, the pitch of an oscillator, the gate of an oscillator, so whether a note was on or off. It could be used to program a sequence. It could be used as an LFO to modulate the frequency cutoff of a filter. So you get the picture. To demonstrate what CV is, I want to show you inside of Ableton Live by sending a CV signal just into an audio track. So I have this tool called CV Shaper loaded up. This is from CV Tools and Ableton Live. And I have this control voltage signal routed to this track called in, which is right here. So if I hit the in to monitor the input, we'll be able to see the control voltage show up right here. And if I change the rate, that'll affect what we're hearing, what we're seeing here. All right, and then we could just take a look at the frequency spectrum, this FFT of what this control voltage looks like. So yeah, as you can see, very similar to an audio signal. It's essentially the same thing. So let's use a CV signal to control something on a synthesizer inside of Ableton Live. I understand this is in a digital domain, so technically these are digital representations of analog signals, but the concepts still hold true. I personally don't have an analog setup or a modular setup, but I want to just explain the concept of what CV is, regardless of if you use analog synthesizers or you work strictly in the digital domain. All right, so I have a pad on an operator, which is just a stock synthesizer inside of Ableton Live, and I'm just going to load up an LFO. So this is a control voltage signal. If I hit map right here, I can then send this control voltage signal to control any one of the parameters inside of operator here. So if I select the fine tuning of this oscillator and hit play, you can hear that CV signal is now controlling the fine-tuned pitch parameter of my synthesizer. So let's fine-tune this a little bit and use it more as like a vibrato. Now you can hear the CV signal is generating a vibrato by controlling the fine-tuned pitch parameter of my synth. So let's talk for a moment about the similarities and differences between MIDI and CV. Control voltages are measured in volts, and in an analog synthesizer, the range of this voltage can vary. So it can be plus or minus 5 volts, plus or minus 10 volts, and a common implementation of control voltages to control pitch on an analog synthesizer is with a concept known as volts per octave, where 1 volt was the equivalent of 1 octave. So if your analog synthesizer had a range of plus or minus 5 volts, that would equate to plus or minus 5 octaves. When using a CV signal to modulate or control a parameter of a synthesizer, it's a bit smoother. There's less chance of having like a zipper or stair-steppy effect. So because of that, CV signals make for great modulation sources. Okay, so if we have MIDI and MIDI CC, why use CV in the first place? Well, aside from the resolution being better, one main reason is if you have analog synthesizers that generate control voltages. You can use something like a CV to MIDI converter to utilize those control voltages from an analog synthesizer and bring them into your digital audio workstation to use them to modulate or control parameters inside of a soft synth or something else inside of your DAW. So one of my favorite things about control voltages is that you can combine multiple signals to generate new control voltages. So let me show you what I mean. All right, so as you can imagine, you can get very creative and come up with some very sophisticated and unique control voltage signals using this method. So I encourage you to try this. And I want to mention that although I'm doing this in the digital domain, the same principle applies if you're working in the analog domain. So if you combine two different CV signals with an analog synthesizer, the exact same thing will happen. You You can combine them together, which will result in a new CV signal that holds qualities of both of the CV signals you're adding together. So aside from analog synthesizers that still utilize CV today, there's also a lot of digital plug-in and DAW manufacturers that offer tools to use control voltages. So you have companies like Polyverse, who you can generate control voltage signals with Gatekeeper or receive control voltage signals to modulate parameters inside of Comet. You also have Ableton Live and Reason and Bitwig, and I'm sure there's a ton of other VST and DAW companies that are utilizing and making use of control voltages that I'm forgetting about. Okay, I hope you found this useful. I hope I maybe cleared up what control voltage is and how you might use it and whether or not it's better than MIDI. It's just different. It's another creative tool that you have at your disposal. So I would encourage you to dive in and have fun and explore the concept of control voltages and see what kind of creative ideas you can come up with. And it doesn't matter if you don't have analog synthesizers like me or not, you can still have fun with control voltages and use them as a creative tool in your toolkit. All right, thanks so much for watching. If you enjoyed the video, please consider giving it a like, leave a comment, let us know what kind of videos you want to see in the future, and I'll see you next time.